Good morning. I got a bit later today due to some reason. By the way, next week onwards, we will start sharp at 6, right? Uh, we are going to start with question number 1, uh, paper number 2, question number 1. So as we have 4 hours for the class from 6 to 10, hopefully we can cover all the paper. Let's see. In question number 1, they ask, write the rth term TR in the expansion of root 2 plus 7 to the power 105 whole thing to the power 10 and find the sum of the rational terms uh, in the expansion. Right. When we consider about root 2 plus 7 to the power 1 by 5, root 2 plus 7 to the power 1 by 5 to the power 10. So the regarding lesson is binomial expansion. In this binomial expansion, you have to expand this particular binomial, which is root 2 plus 7 to the power 1 by 5 to the power 10. There, you know that by using binomial expansion, it is not about expanding this, but about analyzing. So in this analysis, what you have to find the sum of rational terms. What are the rational terms? Rational numbers. So terms are regarding to the expansion. It means that terms which includes the rational numbers. So in particular, the coefficients. X's are the real variable. X cannot have any rational. We don't have X here in particular. So it is about numbers. So the issue is we have already a rational term as root 2 and we have already a rational term as 7 to the power 1 by 5. Why they are called rational terms? Rational numbers are the numbers which are represented, which can be represented as division of two integers. So normally roots are the numbers where you can represent as rational numbers. So obviously root 2 is a square root which is not rational. 7 to the power 1 by 5 is the fifth root of 7. 7 of the fifth as the power is 1 by 5. So it is also not rational. So the thing is this. By considering, first of all, we have to consider the definition now. By considering the definition, it is going to be sigma r equals 0 to 10. R equals 0 to 10. You know that? Why we start with r equals 0? The case is this. For the power 10 for binomial, in start we discuss of this lesson, we always have more than one term of the number. So here we got 11 terms. That is usually why normally for sigma we start with r equals 1 as we deal with the positive integers. By the way, this is also about the positive integers. The first term is going to be t1. There is nothing like t0. So exactly why we start with r equals 0 to 10, because we have to have 11 terms and the general term is considered to be tr plus. That is why. So when you substitute r equals 0 for tr plus 1, t1. When you substitute r equals 10 for tr plus 1, t11, likewise. So yeah, let us write down the general term. 10 cr, root 2 to the power, root 2 to the power 10 minus r, root 2 to the power 10 minus r, 7 to the power 1 by 5 to the power r. Clear. So how I expanded? X plus y to the power n, r equals 0 to 10, r equals 0 to n, ncr, x to the power n minus r, y to the power r. Right. Now you have to think to get rid of these irrational terms to make the output rational. So there you have to consider about this power, right? So you have to consider about this power. 10 minus r and r. To make root 2 a rational number, you have to always power up root 2 to even power. Root 2 to even power. Root 2 to odd power always includes root 2. So root 2 to the power 0 is 1. Root 2 to the power 2, root 2 to the power 4, 6, 8, 10. So here you can have, to make root 2 rational, you have to have 0, 2, 4, 6, 8, 10. To make 7 to the power 1 by 5, uh, the output, when you power up as rational, it should be uh, 0, 5, 10. Clear? So you can do like this. Here itself, you can write down the numbers you need to make it rational. So there it is going to be 0, 2, 4, 6, 8, 10. Until 10 you can substitute for the right. By the way, when you substitute 0, it is root 2 to the power 10. When you substitute 10, it is root 2 to the power 0. Right? So here, 7 to the power 1 by 5 to the power r. Things you have to substitute are 0, 5, 10. Out of these two, you have to go simultaneously. No? I mean, it is not just enough to substitute for one. I mean, altogether for the output, you have the product of everything, not only these two, but also 10 CR. You don't have any issue with 10 CR. So there is where you choose 0 and 10. Why is that? In common, those are the numbers you have to substitute to get rid of irrational terms. 5 is not in common. So you can see sum of rational terms here. Sum of rational terms by selecting 0 and 10. 0 and 10. So sum of rational terms, you have to substitute 0 for r and 10 for r. So 10 is 0, 2 to the power 10, 7 to the power 1 by 5 to the power 0, plus, plus, so I'll write down here to be more clear, 10c 10, 10c 10, 10c 10, so you have to substitute 10, 10c 10, 2 to the power 10 minus 10 is 0, so it has right away write down 0. And when you substitute 10 there, it is going to be 7 to the power 1 by 5 to the power 10. And by the way, you know that 10c0 is equal to 10c10. So you can see in the side, you can calculate that 10c0 equals 10c10 equals 10 over, calculate 1 over 10 into 0, which is 1. Which is 1. So this is going to be 1. Root 2 to the power 10 is 2 to the power 5. Root 2 to the power 10 is 2 to the power 5. Why? Root 2 is 2 to the power half. Half into 10 is 5. So it is going to be 32. So this is 1 into 32 into 1. Anything to the power 0 is 1. Plus 1 into 1. 7 to the power 1 by 5 into 10. 10 over 5 is 2. This is going to be 49. So sum of rational terms are 32 plus 49, which is going to be 81. 81. Is that clear? So hopefully you might have done it properly. Correct. Or if you have something to note down, I'll give you a minute to note it down. When I discuss, I mean, it is better to note down nothing. Just listen to me as this is online. Then I'll give you some time to write. Take a minute to write down. Okay, question number 2. Question number 2. In question number 2, we have a limit. Find the value of the real non-zero constant k such that, I mean, because of the rain, the sound might be a bit unclear. By the way, you can hear me clear, eh? If you have any issue, please, I mean, yeah, please give me the comment. It's like raining heavily. That is that. Find the value of the non-zero constant k such that, by the way, it is like apparently not about, I mean, it is about, obviously, you have to calculate for the limit. By the way, not about right away to find the value of the limit because they have given the value of the limit. You have to find that unknown k, right? So this is what you need to do in such a situation. You have limit x tends to 0, 1 plus k squared minus 1 minus k squared over 1 plus k squared x2 minus 1 minus k squared root. Right. So this is what you have. This is what you have. So it is not to show that it is the answer is equal to 1, but to find k. Now, by the way, we know how to solve a limit. So this doesn't seem any limit regarding to trigonometry or regarding to the infinite limits. But algebraic, by the way, let us use our strategies to solve this limit and to have the answer in terms of k. Then by making that answer equal to 1 as they have given, we can find k. Right, so let us start. Equals, first of all, I mean, you cannot directly substitute obvious, 0, 0. That is the issue. So the strategy is apparently you cannot see any direct, I mean, any formula to directly substitute. So the algebraic formula is xn minus a n over x minus a. So you cannot see that here. So you have to use your normal strategies, which are like when you have difference of two square roots, you use the conjugate. So let us use the conjugate and let us span this. Let us expand that. X tends to 0, 1 plus 2kx plus k square. Though either you can go in difference of two squares way as well without using the. So let us right away use difference of two squares. That is better a square minus b square, a minus b, a plus b. 1 plus kx minus 1 plus kx, 2kx. 1 plus kx plus 1 minus k, 2 over. Here, once you multiply this by the conjugate, you have 1 plus k squared x, 1 plus k squared x minus 1 minus k squared x. So, the remaining part of the conjugate plus 1 minus k squared x. Right? So now you can take 4k out as they have given a as a constant, not depending on x as a constant. So by the way, 4 out, 4k out. Limit x tends to 0, you have x here over 1 to 1 cancelled over 2k squared x. So you can take 2k squared out as well out of this particular part of the limit. So 4k was out, x was remaining in the numerator, 1 to 1 cancelled out, k squared x, 2k squared x. Now x to x can be cancelled out because x is not 0. If x is not 0, it tends to 0 only. Clear? So into, let us evaluate the limit of the remaining part of the conjugate where we multiply. So limit x tends to 0, 1 plus k squared x plus 1 minus k square x. When x is 0, this is 1 plus 1 is 2. So you can take, I mean, this is right away 1. Limit x tends to 0, 1 is 1. It is a constant. So this is going to be 2 to 2, 4, k over k square is 1 over k. Now you can argue after that, but this 1 over k should be as they have given 1. Therefore, k is 1. Therefore, k is 1. Got it? Again, I'll explain you. By difference of 2 squares, I got 2kx into 2. Then in the term in the bottom, I simplified with the conjugate. Multiplied with the conjugate, then the remaining part of the conjugate is there. Then I took 4k out right away, x remaining. Here 1 to 1 cancelled out, then 2k squared out, x remaining, that is done there with the cancelling out part. Then I again substituted to have 2. Yeah, there I made a mistake. With the rush, I made a mistake. Because this 2 with the bracket, I write down here. So I thought that 2 is regarding to the denominator. But 2 obviously is at the numerator part. There is no fraction there. So it should be like, even though I marked there, it should be cancelled out with these 2 to have 4. So the final answer is not 1 over k, 4 over k. 4 over k is 1, k is 4. Okay? That is why you have to be careful. So in making those mistakes, you have to learn that I'm not going to make this mistake again. So because of that, I made this bracket here. I thought that R2 is regarding to the denominator, then cancelled out this 4 is the top. Now we're looking. Case 4 is the correct answer. Okay. Right. So I'll give you a minute for the corrections. All right, question number 3. By the way, number of students are not here. Some of you already requested for the recordings because of the school. Um, and yeah, basically because of the school. But I expected like with the count 14, 15 to be here. We'll see why. So continuing the process. Question number 3. Question number 3. When we consider question number 3, it is about area under curve. Question number 3 is about area under curve. So they are sketch the graph of the functions y equals x minus 2 squared and y equals 4 minus 2x in the coordinate plane. Show that the area bounded by these graphs. So to sketch y equals x minus 2 squared, you have to have some certain data set. So you again have to sketch 4 minus 2 y equals 4 minus 2. So in sketching this particular parabola, the shape will be parabola here as the function is quadratic. Here the shape will be a straight line as the function is linear. So let us find out the cutting point of y-axis by applying x0. So it is going to be y4. Let us find the cutting point of x-axis by applying y0. So x minus 2 squared is 0. So x is 2. Then the turning point, and the dot picture, locate right on PP. So in the turning point, you normally have to make the standard equation into the completed square form. Standard actually the function into the completed square form. By the way, in this particular question, as the way they have given the function, it already completes its square. So it is going to be a minimum in particular, as y is x minus 2 squared. Coordinates of the minimum is 2, 0. They are 2, 0. So here, cutting point of x-axis by x0, y is 4. Cutting point of y-axis by x0. Cutting point of x-axis by y0. So 4 minus 2x is 0. 2x is 4. X is 2. X is 2. Then you just have to fix the graph y-axis and x-axis with your origin. X2, y4 and minimum is 2, 0. X2, y4 and the minimum itself is 2, 0. So this is going to be the graph. And here x2, y4. X2, y4, the same point. So it is going to be x2, y4. Right. So naming the graphs, this is y equals x minus 2 squared and this is y equals 4 minus 2. If we have any issue with sketching graphs, that's the basics because we know we sketch advanced graphs in calculus, in particular applications of differentiation by the way. So what is that area bounded? This is that area bounded. Obviously, you don't need to even find out the cutting points. By the graph, you can see they are 0, 4 and 2, 0 by the graph. Otherwise, you have to find the coordinates of the cutting points by simultaneously solving the equations. No? Right. So here you can see the area bounded by marking the area. Area bounded. Area bounded equals 0 to 2 because we have to have x-axis values because it is about the input. The output will be the graphs and the area. So 0 to 2. You have to find, you have to note down here as boundaries. So the area, the larger area is with the straight lines of 4 minus 2x. 4 minus 2x. You have to 3x. You have to subtract area created by the parabola x minus 2 square. 0 to 2 x minus 2 square. Right. So what about x minus 2 squared? X squared minus 4x plus 4. Plus 4. There you can obviously cancel off 4 to 4 and the limits are the same. I mean, there is no point of calculating this 4 and that 4. Right. By the way, they are going to be cancelled out. So 4 minus 4 minus 2x plus 4x plus 2x. That is what you have to evaluate, plus 2x. So 0 to 2 dx. Done. Then 4 done, minus 4x done, and minus x square. Minus x square. Minus x square dx from 0 to 2. Finally, there is going to be 2 into x squared by 2 from 0 to 2 minus x cubed by 3 from 0 to 2. So 2 to 2 you can cancel out. 4 minus 0, 4. And this is minus 1 by 3. 2 cube minus 0 cube, it is 8. So finally, you will have the area as, yeah, you have to write down the units as spare units as well. So it is going to be 12 minus 8, 4 by 3. Finally, 4 by 3 square units. So the point here is, or the points here are, in evaluating these two integrals, you have to know those basics of integration. Otherwise, you are like evaluate the integral of 4 minus 2x, x squared minus 4x and 4. As far as you are with the same limits of these definite integrals, you can simplify by taking the equal terms together to evaluate the final integral. Is that clear? Right. So that is it. You can do the corrections by now. Okay, question number 4. Up to question number 3, we completed. Now, question number 4. Question number 4. In question number 4, we have they have given. Yeah, it is regarding to coordinate geometry. Let us see both the circles and straight lines. They are or just only one lesson we have to use. Let A be 2 minus 1 and B be 4 minus 3. The point C 3t comma minus t, which t is real. By the way, you know that t is a real parameter, lies on the perpendicular bisector of AB. Find the value of t and then find the coordinates of the point D such that ACBD is a rhombus. Alright. Find the value of t. Let us first find the value of t. So as they see, there is AB. There is AB. Lies on the perpendicular bisector of AB. Lies on the perpendicular bisector of AB. Bisector of AB. So you know that A is 2 minus 1. A is 2 minus 1. B is 4 minus 3. B is 4 minus 3. The point C, 3t minus 3. T, 3t minus 3. Alright. You have to find the value of t. Ne? Yeah. Obviously, let us take, to find the value of t, you have to use some data, no? To use that data, as far as C lies on the perpendicular bisector of AB, it can be either the midpoint of AB or any other point, but they haven't told us in particular it is the midpoint. So it should be uh, like we have to consider it lies as generally somewhere else without being the midpoint of AB. So first let us find the midpoint of AB as they have further given I'll use this as E. So in finding the midpoint of AB, which is E, you can use the ratio theorem. You can say by internal ratio, E is going to be 4 plus 2. 4 plus 2 over 2 minus 3 minus 1 over 2. So E is going to be 3 minus 2. That is E. E minus 2 is E. Now we used that property as they have given bisector. So bisect means dividing into two equal parts. Perpendicular, we haven't yet used the property perpendicular. So as already as I have marked E, as CE is perpendicular to AB, CE is perpendicular to AB, you can now use product of gradients to be minus 1. Now you can see as AB is perpendicular to CE, MAB into MCE is minus 1. Minus 1. In MAB, it is going to be difference of y. So minus 1 minus minus 3 is 2. Over 2 minus 4 is minus 2 into MCE. So you know E now. So you can have the difference again. Minus 2 minus minus 3, 3 minus 2. 3 minus minus 3 is 3 out. 1 minus 3 is minus 1. Right. Then multiplying both sides by minus 1, you can get rid of this minus. So further you can have, yeah, t minus 2s, t minus 3t, t minus 3t. 4t equals plus 5t equals 5 by 4. So you just got the answer of t to be 5 by 4. Is it clear? So they just told us that particular point C is lying on the perpendicular bisector of AB. They have a particular told that it is in particular the midpoint. That is why we Yeah, generally we mark, right? So actually this T is yeah, in particular, um, you can say T is not a parameter here. T is not a parameter here. Why I say that? T to be a parameter at first, like the way they have given in that new syllabus papers, I saw that they are not like in the marking schemes as well. They are not specifying T to be a real parameter by the words. They just say T is like just uh, belonging to the real number set. Yeah, so there we have to have that idea after analyzing the answer. So here as well, T is not a parameter, it is just a number, just a term. I mean, T to be a parameter, depending on the location of T, we have to have like T varying. It should be varying, but here T exactly has got one value to be 3T minus T as far as that is on this particular straight line, there can be only one answer for T, that is why, right? So think about it, it is not a parameter, right? Further, T and then find the coordinates of the point D such that ACBD is a rhombus. ACBD is a rhombus. Now you know CNA. So when you consider about ACBD, you have this ACB, A, C, B, B. ACBD to be a rhombus. So you know that A is 2 minus 1, C is 80 minus T. So 15 over 4 minus 5 over 4. That is C. Then B 4 minus 3. 4 minus 3. We don't know about D, by the way. Let us mark D there. X D by D. So what you are going to use to find D when ACBD is a rhombus. So what is a rhombus? All four sides are the same. Opposite angles are equal. And yes, obviously, diagonals are bisected perpendicularly. So that property you can use. The perpendicular property, I mean, there is no point of thinking of that anymore because we have already used that. By the way, that bisecting part, we thought it, I mean, we used it on AB only. So you can use CD as well, as these are AB, CD, AB, CD. You already know the coordinates of B. So by the way, yes, you can even go for the external division as this is D is outside, right? So here you don't need to again think about AB. It is just CD as you know EB, as you know E. So E is 3 minus 2. So you can either think of the internal division and make XD and YD the subject, or you can think of external division right away to have XD and YD. So let us apply external division as we already have used the internal division for a question. So you can say by external division, XD, what is going to be XD? XD, oh, right away let us say, I mean, let us find out the coordinates of D right away. So what is D? As D divides CE externally at ratio 2 to 1. 2 to 1. So it should be obviously 2 to 1 division. There you have to multiply this by 2 and 1 by here. Right? So it is like this. If I separate the line here, you have D here and yeah. Here E is 3 minus 2, C is 15 by 4 minus 5 by 4. D divides T to the ratio 2. D divides E to the ratio 1. Clear? So they are in having the coordinates of D, it should be uh, I mean, 2 comes from here, it should be this, and that is why in marking this one, it is better to mark this as one. Now it is clear. I mean, you have to, I mean, 2 generates from these coordinates and 1 generates from these coordinates. So 1 should be multiplied with these and 2 should be multiplied with as per the pattern. So D is going to be 2 into 3, 2 into 3 minus 2 into 3 minus 1 into 15 by 4. 1 into 15 by 4 over 2 minus 1, comma, 2 into minus 2, 2 into minus 2 minus 1 into minus 5 by 4. 1 into minus 5 by 4 over 2 minus 1. Sorry, over 2 minus 1. Over 2 minus 1. Now you can see that. Over 2 minus 1. There, right away, let's write down the answer of P. 2 into 3 is 6, which is the one you have here. 24 minus 15 is going to be 9 by 4. 9 by 4, comma, minus 4 plus 5. Plus 5 minus 4 minus 16 plus 5 minus 11 no 4. Minus 11 no 4. So those are the coordinates of B. Clear? It is not that hard type of question because the simple things they ask about the perpendicular bisectors, I mean the perpendicular scenario and the bisecting, right? So if you have any question, you can ask at any time. Just turn the mic on or put a comment and ask. So it is time for the corrections. All right. The next question, which is question number 5, we are going to discuss. Question number 5. Question number 5, you can see another coordinate geometry question, which is regarding to circles. It's regarding to circles. There, there. Find the equations of the circle that touch the coordinate axis and the straight lines that touch the coordinate axis and the straight lines. All right. And the straight line, 3x minus 4y plus 12 equals 0. So what about the slope here? Slope is positive. All right. Find the equations of the circles. It should be equation of circle. So let us see. My simplify. So as the circle is there, obviously when we consider about the straight line, gradient is positive. So we can think of in the diagram, obviously we have yeah, let's see. So this is about the straight line. So let us go with the straight line first, as they have given. What is that? 3x minus 4y plus 12 0. So let us separately mark these things in data. So that is better because we don't know. We don't need to consider our time to have the decision about the exact diagram. We just need to sketch and go forward, right? So you don't know about, obviously, you have to find the equation, know the equations. Let us see. I'll introduce the circle. Let the circle be in the general form. So let the circle be x squared plus y squared plus 2gx plus 2y plus 0. I introduce the circle. By the way, at the same time, let us think about the other two data as well. What if we can find out of the unknowns? We have three unknowns, like G, F, and C. If we can find out the unknowns before to this by using those data, it will be useful. Equation of the circle that touch the coordinate axis. Coordinate axis. They are to touch coordinate axis. We don't know what the coordinate, right? So we just mark it in generally here. So this is what when it touches both the coordinate axes. Right. So x is y0, y is x0. Alright. So there the thing is this. According to the symmetry of this circle, you can say one thing. What is that one thing? Both the coordinates are the same for the center as it touches both the coordinate axis. So here you can see by it, and you already have considered the circle to be this. So here you have to say by symmetry. So by considering actually circle geometry by symmetry, minus g should be equal to x. So g is x. G is x. Minus g is minus x. Both the coordinates are the same. There, for the radius, you can use when you consider about the radius. Radius is again going to be 1 of g of f. I mean, here you have g and f. They are the same with the value only. It can be either plus or minus. It depends on the quadrant. By the way, you can further say further how we can have the formula of the radius. R equals square root of g squared plus f squared minus c. R equals, right? So by the way, here the radius is equal to g of f but you cannot consider the sign. The radius should be plus only. So I'll go with G. I mean, instead of, I mean, for G it is G. Instead of F, I'll put G. So you can say further, modulus of, regardless of the sign, we don't know about G. We just sketch, we just sketch to that to be on the first quadrant, but we never know. So square root of G squared plus F squared is also G squared minus C. So let us square both the sides. Now you don't need the modulus. 2G squared minus C. C squared going to be, C is going to be G squared. C is going to be G squared. So up to that, we are okay with the three, I mean G is F, C is G squared. Everything you have in terms of G. G is G, F is G, C is G squared. So you just need to find G. That is it. So by here, that is why we went to there by keeping this. So let us go for here. You know that the center now is after that. After this, you know that the center is minus D minus. You can mark the center as minus D minus D. And the radius you already know as modulus of G. So you can see here, the special thing is radius, the value of the radius equals to perpendicular distance to the straight line from the center. So what about the radius? Modulus D equal to modulus of yes, minus G minus 3G minus G plus 4G plus 12 over 3 square plus 4 square root. So let us go for the square. So G square, this is going to be root 25 5. So 25 G square equals, so this is going to be 25 root is 5. 5 modulus G square, 25 G square equals here. You have G plus 12 square. G plus 12 square, right? So by the way, 25 G square equals G square plus 24G plus 144. There, 24G square minus 24G minus 144 equals 0. You can divide everything by 12, eh? 12. So dividing by 12 or 24 by 24 even you can, eh? G square minus D dividing by 24, it is going to be 6. Minus 6 equals 0. So G minus 3, G plus 2 equals 0. G minus 3 is 0, 4. G plus 2, 0. So G is going to be 3O. G is going to be minus 2. G is going to be 3O. G is going to be minus 2. That is exactly why. Now we can decide that missing part. These are going to be circles. So you can finalize the circle. Therefore, yeah, the first circle is going to be the space is not enough there. So I'll give you the circles by the way. Once then you can write down the circles now. Once G is 3, so let us write down the values here. Once G is 3 and once G is minus 2. Once G is 3, F is also 3. F is also minus 2 for that set of values. So once G is 3, C is 9. C is 9. Once G is minus 2, C is 4. So in determining the circles should be x squared plus y squared plus 6x plus 6y plus 90. Here x squared plus y squared minus 4x minus 4y plus 40. Those are the circles. Clear? Even though the question looks very little with instructions and just one line. So you have to decide everything by yourself, even though this is the point. I mean, all the other things are not that harder. The things we have been like doing frequently. But here, this is the point to make G and M equal. Thereby, you got everything, right? Okay. Do the corrections. Now, question number, we completed up to question number 5, right? Now, question number 6. So, moving to applied maths from the oven. Applied maths from the oven. Right. There. Right. Question number 6. Two particles P and Q of mass 2m each are attached to the two ends of a light inelastic string which passes over a smooth fixed pulley. The system hangs freely in equilibrium under gravity. Uh, yeah, gravity. The string taut and the portions not in contact with the pulley vertical. Another particle of mass m which is released from rest from a height h above P collides with P and coalesces. Uh, and the composite body commences its motion. Find the initial velocity of the system and the impulsive tension in the string due to the jerk. All right. So let us be theoretical of thinking. I mean, without analyzing the thing practical. By the way, this is what you have 2m, 2m, E, 2mn, Q, 2m initially. They are taught by the way. So in initial stage, it has got some tension. Some tension. Let us say that is, By the way, we don't have any motion since the system is balanced. So after that, when they say, yeah, there is a mass M which is been dropped into above P, collides with. So with the height h, you have another mass with M. They name the mass? No. So let us just the mass. They have given the mass only. So mass is M. Let us name that particle by the way as S is mass M. So what happens after you gently releasing that particle with the mass M? After height h, it will collide with particle P and collides. They they will be together as one particle, and with that collision, there happens that yeah, the impulse, but that impulse happens at the string. That is why they ask for the impulsive tension. Then they will move after that. I mean, just after that, they are getting a certain velocity. Then they will move. Since then the system is not balanced, right? So this is going to be the next stage when they get together. It is the occasion of impulsive string. So it is going to be they are together now. So you can say this is P and S. Now the mass is 3. Here it is Q. Mass is 2. Sorry. Impulsive string. Impulsive tension for the string. By the way, so just after the impulse, what they have is with the velocity, they will start their motion. One is up and the other one is down for obvious. As far as they got connected by a string, they have to have the same magnitude of the velocity, so the speed. So after that, this will go down with V and this will go up with V. All okay. By the way, we have to find uh, the velocity just before the collision. So it is here just before the collision. They all mark it separately. So S comes is in with that velocity. What is the velocity after I take by applying? You can say by applying v squared equals u squared plus 2s for p. For p, we are applying 2 down. V squared is going to be 2ga. V is going to be 2da, 2gh. So for that way, so let us write down this as u, as I have already used v there, u. All right. So it comes with that velocity v, and they are together after that. Is p and s with masses 2n plus m, 3n. So I'll mark the velocity as u. There doesn't happen any impulse between the particles as they collide and collides. Had they not been collides, it would have been impulse between the particles as well. So here what you can, what you can apply for the in finding u is, yes, it is going to be as they have got, nothing regarding to, yeah, but what about the external impulses you have here? Let us explore that first. So in these particular collision, they collide and collides, ne? Yeah, that is for X. That is for X. Ah, sorry. I marked it as P. That is for X. For that falling under gravity particle within X. But in applying these for these two, what you can do is you are applying I equals delta MV. Applying I equals delta MV down for P and S together as it goes together after the collision. So I is going to be for the two particles together is Pi. No impulse in between the two particles. So it is going to be minus Ti because yeah before to it didn't have any impulse, but in between the collision this is what happened. So it is upwards, I'm up and downwards. So it is going to be minus Ti equals the difference of the linear um, momentums. So it is after minus before. It is going to be Pm into u minus m into, that is minus Ti. Now let us applying I equals delta mv to up for q. There you have Ti equals 2m into u minus 0. U minus 0. So Ti equals 2mu. This is 2. This is 1. By 1 and 2, you can obviously find what they ask. Find the initial velocity of the system and the impulsive tension, both. So by simultaneously solving, you can have both. You can say by 1 plus 2, it is going to be 5mu minus mv is 0, m2n. V is going to be 5. Sorry, it is about u we need to find. U is going to be v over 5. U is going to be v over 5, which is root 2gh over 5. An impulsive string now by 2. Impulsive string is 2mu. 2m root 2gh 2mu. So yeah, u is here. Root 2gh over 5. 2m root 2gh over 5. That is the answer. Got it clear? Right. So you can do the corrections now. Do the correction. All right. Next. So up to question number 6 done. If you have anything to like make it clear, please ask. So it is about, and surely you will have such question. Since up to 2018, before the syllabus, the recent syllabus, uh, there are you, there are the students got 4 questions altogether with the lessons statistics and probability. 7, 8 probability, 9, 10 statistics. But 2019 onwards, 9 probability and 10 statistics. They are, yes. So to compromise those 2 questions, what they have applied is impulsive tension question and one more with the other lessons, like it is like varying with the year. So the first question is obviously with the collisions of 2 spheres as per the trend with years. And here you have, they include for the years impulsive tension question. No, you cannot apply hyper delta and V for the system. Don't try to go for the system when you have a string. It is complicated. Apply for the system when you have like pitch and the particle. Here, do not go for the system. System is not about, so you can obviously consider about a system by considering these 2 particles. Don't think by looking at the looking at 2, 3 particles, everything can be considered that as a system all the times. No. Normally, when they are connected by a string, it is better to not to consider as system all together, but separately. Right? Question number 7. Question number 7. In question number 7, you have, yeah, as you expected, as you talked, there is the question. 2 smooth identical elastic spheres of masses m and km move with the velocities phi and nu respectively in opposite directions on a smooth horizontal plane and collide directly. After the collision, the velocities of the 2 spheres are equal in magnitude to exactly half of the initial velocities, but in the opposite directions. Find the value of k, the coefficient of restitution between the 2 spheres and the impulse which acted on each sphere due to the collision. All right, so let us hit the collision. They're like coming together. Answers M and K, they haven't named it. I'll name M and K coming with the velocities m5u, kmu, m5u, kmu. All right. In opposite directions on a smooth horizontal plane and collide directly after the collision, the velocities of the 2 spheres are equal in magnitude to exactly half of the initial velocities, but in opposite directions. All right. Of them, right? Exactly half of 5u for A, exactly half of u for AM and opposite direction. It is going to be 5u by 2 and 2 by 2. AM, B, AM. So this is the impulse due to the collision. Clear? They ask, impulse and first the value of A. Have they given E? No, find the value of KE. Yeah. KE and the impulse. We have to find 3. Right, so let us apply. You know that in the new syllabus, we are not applying directly conservation of linear momentum. You have to apply always I equals delta mv. So let us apply I equals delta mv. Applying I equals delta mv for system. 0 equals km into u by 2 plus m into minus 5u by 2 plus m into u, not plus, it should be minus, plus the minus n into 5u, n into 5u, so this plus minus n into 5u is plus, so plus m into minus u. All right. Yeah. Then here we can find a, hopefully m's you can cancel out. Then 0 equals ku by 2 minus 5u by 2 minus 5u plus ku. So it is 3ku by 2 equals 15u by 2. 2 to 2, 50 to 3, 5. U to u, k is 5. Therefore, k is 5. Now let us go for Newton's restitution. So applying Newton's restitution law, you have write down Newton's restitution law. Yeah. Then applying Newton's restitution law, you have to go for a convention now. Let us go for velocity of B to A. Considering velocity of B relative to right hand side. Velocity of B to A as they travel in two opposite directions, you have add. So there you have u by 2 plus 5 by 2 velocity of b over a to right? So 6u by 2, which is 3u, over velocity of b relative to a. So to left hand side it is u plus 5u, 6u. To right hand side it is minus 6u by the way. As I have informed you already, don't go for the division. Go for, the relative velocity after the collision equals minus e into. Don't go for the division because we have a clash here as division is not defined for it. So 3u equals minus 6u into minus 4 minus e into minus 6. Always minus e into that velocity. Minus e into, when you consider about velocity of b with relative to a, it is towards left 6u, but towards right you have to consider that is minus 6u. So this to this you have to, so e is going to be half. E is half. That is done. Now the impulse. To find the impulse, let us apply for any of these. I'm going to apply for B. For B. You are going to apply for B, I equals delta mv to right hand side. So it is going to be I equals kn. K is 5. 5n into u by 2, minus u. Minus u. There I is u by 2 15 nu by 2. That is the impulse due to the collision. Right? If you have any question, please ask. And you can correct now if you have any corrections to be done. All right. Question number 8 we have to do now. Question number 8. Right. Discussing question number 8. Question number 8. It is about vectors. Right? There, they say A and B they have given. Lambda and mu are real constants such that mu is positive and ij are the usual unit vectors. If B modulus is 1 and the two vectors A and B are perpendicular to each other, find the constants lambda and mu. Right. So, question number 8. They have given A as 2y plus 3j, B as lambda I plus uj. Mu is positive, which will be important. Going further, are the usual unit vectors. If B modulus is 1, you can see if B modulus is 1, lambda squared plus mu squared root is going to be 1. So lambda squared plus mu squared is 1. Then the next, two vectors A and B are perpendicular to each other. So it's not that hard. You can see since A vector is perpendicular to B vector by dot product A dot B is 0. Because the angle is cos 90. The definition of A dot B is A modulus B modulus angle in between. Since they are perpendicular, angle in between is 90. So cos 90 is 0. A dot B. So 2y plus 3j dot lambda I plus mu j is 0. 2 lambda I dot I plus 3 mu j dot j is 0. I dot j, j dot I are 0. So I considered I dot I as 0 j. 2 lambda plus 3 mu is 0, 2. So you can substitute by 2 to 1. Lambda equals minus 3 mu over 2. Okay, then 9 mu squared over 4 plus mu squared is 1. There you have 13 mu squared is 4. Mu is going to be 2 over root 13 or 2 root 13 over 13. Because of that, mu should be positive. I considered positive value only for the square root. Now you can use now as lambda is minus 3 mu over 2. Lambda is minus 3 over 2 into the value of mu 2 root 13 over 13. 2 root cancelled off. Lambda is minus 3 root 13 over that is going to be the value of lambda after the value of mu. So since they recommended that mu should be positive, we got the positive answer only for mu. Then continued until we got lambda. Right. Do the corrections. All right. Next question. To question number 8 done. Now question number 9. Question number 9. In question number 9, they ask, yeah, find the minimum force that is required to move an object of weight W upward slightly along the line of greatest slope of a rough plane inclined at an angle alpha to the horizontal. The angle of friction between the object and the plane is lambda. All right. So question number 9. The angle is alpha here. Right. Minimum force that is required to move an object of weight W upwards slightly along the line of greatest slope of a rough place, rough plane inclined at an angle alpha to the horizontal. So it is about yeah, move upwards slightly. So weight W. Weight W. All right. So by marking the weight as W, you have to move this up. So it should be, let us mark that external force as P. As you try to move it up, the friction forces to down, and the perpendicular reaction is there as well. Right. So let us mark everything now here. Let us make equations to find the R and F, then we can argue. So let us do this. The thing is, still it is about the minimum force that is required to move an object. There, it is about just to move upwards, right? So it should be, here you have to consider the limiting equilibrium, but in particular considering limiting equilibrium directly, we'll consider about the equilibrium of this particular object. Then we can further argue after the equilibrium of this object. Then we can further argue with uh, the limiting equilibrium, right? So I'll explain bit by bit. So you can say, considering, so we still consider the object is in equilibrium, then with the arguments, we will consider about the minimum force. Considering equilibrium of what is the object? Equilibrium of object. So here I prefer the two components to be in along the plane and perpendicular to the plane. So here perpendicular to the plane. So B is 0, then R minus W cos alpha is 0, R is W cos alpha 1. R is W cos alpha 1. Then along the inclined plane is 0. F plus W sin alpha minus P is 0. There F is E minus W sin alpha, that is 2. That is 2. So you can argue here it is equilibrium now. So F of R should be less than or equal mu. They have given lambda, which is friction angle. They have given lambda, which is friction angle. By the way, you know that mu is also tan lambda. That is the connection between mu and lambda. So let us argue with tan lambda instead of mu. So what about F? By 1 over 2 over 1, you can further consider. By 2 over 1, F is E minus W sine alpha. R is W cos alpha less than or equals and lambda. Let us multiply. Is less than or equals uh, W cos alpha tan lambda plus W sine alpha. That is P is less than or equals. P is less than or equals means that P2, I mean, this is for the equilibrium we considered that to be in equilibrium, this should happen. So it is like we have to consider about that limiting force of P to have the minimum force that is required to move the object to up. It is just to move it. So that is going to be that equal force. For the less values of that P, the object stays in equilibrium. Obviously, for the greater values, it will move. So you can argue, therefore, P minimum equals, or by the words, minimum value of P, W cos alpha tan lambda. There can you go with the further simplifications? They don't ask for a, so that no, that is okay. P min is going to be W out cos alpha tan lambda plus sin alpha. W out cos alpha tan lambda plus sin alpha. Cos alpha tan lambda plus sin alpha once you take W out. Clear? So, yeah, you can do the corrections now. If you have any question, please ask. That is how we argued in general. We didn't consider about the limiting value right away. We considered about equilibrium. So, I mean, to be in equilibrium, what should happen for P and further, right? No, you can't use uh, equations of motions here. It is about equilibrium. All right. Question number 10. For the last question we reach in short question. Question number 10. Question number 10. The particle is projected under gravity in a vertical plane from a point O with velocity u and angle theta to the horizontal. After time t, it moves in a direction perpendicular to the initial direction of the projection. Show that velocity u and angle theta. So velocity is u and the angle and theta. After that time we see it it moves perpendicular direction initial or the initial direction of projection. For after time t, so let us consider this as time 0, this as time t. So this is what you have to use here, geometry. This is theta, 90 minus theta, so this is also theta. So this is going to be theta again. Theta again. We don't know about the velocity, let the velocity be v. Right? Let us name the positions here as b and here as a and here as b. You can see let velocity be v at b. Right. So you know that the horizontal component stays equal for a projectile we consider because we assume that there is no air resistance, that is why. You can see here v sin theta is u cos beta. V is right away u cos theta. We just found v in terms of the given data. Now what they ask, show that t is about the time you have to find. To find the time, what we need to do, let us apply, we have to have the time only, right? No distances are given, nothing. So v equals u plus at. Yeah. From A to B, v equals u plus at to up. Let us apply. So v is down, v sin theta, v cos theta, so it should be minus v cos theta. Equals u up u sin theta. Since you apply to the up, it is minus gt. Let's say gt is u sin theta, u sin theta plus c cos theta plus u cos theta over sin theta into cos theta. Right. So gt is u out sin square theta plus cos square theta over sin theta. Therefore, time equals u over g sin theta. So u over g cos theta. U over g sin theta is u over g cos theta. That is so the vectors. Okay. Do the corrections. If you have any corrections to be done. All right, now we can start essays. uh, the diagram is not fast to scale. You need the diagram because without the diagram, how you can decide the connection between the angles? For the connection between the angles, you need the diagram. Otherwise, it is not a must, by the way, as they don't request us to sketch, but that is for our use. Right. Now we'll start essays. Essay question. Yeah, yeah. The first question itself is from the coordinate geometry. Listen. Question number 11. Question number 11. Find the equations of the angle between the two non-parallel straight lines given by. Find the equations of the angles between. Equations of angular bisectors, it should be. Find the equations of the angular bisectors of the angles between. Equations of the angles between. For angles, we don't have any equation. So it is about angular bisectors, right? Find the equations of angular bisectors of the angles between the two non-parallel straight lines given by, right? So how to have that? It is this. You have like prove angular bisectors scenario. So you have a1x plus b1y plus c10 here, a2x plus b2y plus z20. So by creating a line to be the angular bisector, so let us say alpha alpha, you have to have a common point as px bar y bar. Then by making the perpendiculars, so let us say this is ABC. By considering ABB and ABC to be congruent triangles, you can further say AB is perpendicular to BC. By considering APB triangle is congruent to APC triangle, you can say PB equals to PC, where you have A1x bar. That is the previously proven. I mean, before to this, you have the perpendicular distance formula. You can obviously use that here. A1x bar plus B1y bar plus C1 modulus over square root of A1 square plus B1 square equals A2x bar plus B2y bar plus C2 modulus over A2 square plus B2 square square. So eventually you can have therefore the equations are now it is about lossy of x bar y bar. You can replace xy by x bar y bar by xy. So you can see a1 x plus b1 y plus c1 over a1 square plus b1 square equals plus 1. A2x plus b2y plus c2 over a2 square plus b2 square square root or the negative one, or a1x plus b1y plus c1 over a1 square plus b1 square equals minus a2x plus b2y plus c2 over a2 square plus b2 square square root. Those are the two equations you have to have from the proof. That is the right. So if you have something to write down here, because I'm going to erase this for the result, I'll give you 1 minute. Right. Next. So the proof is done. Now we are going to solve the question and they have given. Right. So there are two sides of a square lie on the bisectors of the angles between the lines 4x plus y by 3 equals 0 and x plus 4y minus 3 equals 0. One of the vertices of the square is 0, 2. Show that there are two such squares and find the equations of the sides of the two squares. Right. The other two sides they say. Right? Right. So by the way, first of all, you have to find, as they say, two sides of a square lie on the bisectors of the angles between the lines. So you have to find the equations of angular bisector. You don't need to do it again as you have proven that before. You can right away use the formula. So you can say equations of angular bisector. Right. How we can have those? OX plus y plus 3. OX plus y plus 3 modulus of root 17 equals x plus 4y minus 3 over root 17. So x plus y plus 3 equals x plus 4y minus 3 over 4x plus y minus 3 equals all the minus 6 minus 4y plus 3. So there are 3x minus 3y plus 6 0 x minus y plus 2 0 or 5x plus 5y minus 6 0. Those are the equations for the given two sides of the square. They are, yeah, after finding that, you can like this sketch the square. So let us say this is the square and we'll name it as A, B, C, D, and we give the respective names. You have the right. I mean, they haven't recommended anything now. So let us give AC x minus y plus 2 0 and to be like to be. I mean, you don't need to depend on everything to get the diagram by the way. So as this has got that negative grading, let us do 5x plus 5y minus 6 0. Here x minus y plus 2 0. That is it. Congruity ratio, right? This is by the equations of the above proof. Right? I will just found those two. Further, they say one of the vertices of the square is 0, 2. So we have to check whether 0, 2 is A, C, D, O, B. That is what we need to check, right? So here we are going to check whether 0, 2 satisfies the or this or the cutting point, or if it is not, that is going to be B. Right. So the point, let us say let E be 0, 2. Substituting E 0, 2 in 5x plus 5y minus 6. Then 5 into 0 plus 5 into 2 minus 6. It is not 0. So it doesn't satisfy. So E 0, 2 in minus y plus 2. 0 minus 2 plus 2 is 0. So obviously it satisfies x minus y plus 2 0. So the vertex can be C or D. Now you have to check whether the vertex is C or D. Right. So you can see therefore E02 is on CD. Right. You have to solve for C. For C, you have to solve minus y plus 2 0 and 5x plus 5y minus 6 0 2. Then yeah, by 1 into 5, 5x minus 5y plus 10 0 third. You can add further by 2 plus 3, 10x plus 4 is 0, x is minus 2 by 5 by 1, y is x plus 2, minus 2 over 5 plus 2, y is 8 by 5. So it is no C means that therefore you can justify. Therefore, one of the vertex, they say, so it can be anything in between C and D, C O D O, anything in between C and D, but as they have recommended, it is one of the vertices. Therefore, D is E, B is 0, 2. So that is the finding up to there. So be clear up to there. Then I'll come to do the further simplifications. If you got it wrong before, now even you can continue. I'll give you like 2-3 minutes. Do it. If you have any question, please ask. Did I do any simplification mistake before? For AC? I just erased, by the way. In having the two angular bisectors, did I commit any mistake with the simplifications? I'll again check if you need. Yeah, I'll check. Otherwise, for the answers we are going to have, everything is affected now. So what we had, x plus 4y minus 3 mod n so equals 4x plus y plus 3 or x plus 4y minus 3 equals minus 4x minus y minus 3. Here 3x minus 3y minus 6 0 minus y minus 2 0. That is okay. X plus 4y minus 3, 4x plus y plus 3. So there you have 3x minus 3y minus 6. X minus y minus 2. I took it as plus 2. Is that the mistake? That plus 2. X minus y plus 2. Can you please? I can't see the comments. That is the thing. Yeah, that was a mistake. That just plus and minus. With that plus and minus, the mistake happened. So let us be clear now. So it should be x minus y minus 2 0. X minus y minus 2 0. This should be minus 2. In the other one, it should be 5x plus 5y 0. With that minus and plus, everything goes wrong. 5x plus 5y 0, x plus y 0. So this is x plus y 0. This is x plus y 0. Now we have to update the things. So make it a lesson. If you go wrong with even a sign, you don't need to go through the advanced simplifications. Once a sign goes wrong, everything goes wrong. So there we have to like x plus y 0. So this should be x plus y. X plus y. So obviously x plus y is 0 plus 2 is not 0 at all. It stays the same. So this should be x minus y minus 2, ne? X minus y uh, minus 2. So it is not 0 as well. So yes. So the point is neither on AC, no CD, right? Neither on AC, no CD. Yes. So it should be surely neither on AC, no CD means that not A, not C, not D, but it is B. It is going to be B. Therefore, yes. So simplified everything. You don't need to do these things now. So you can further say, okay, the thing is this. We found the two angular bisectors wrong with one mistake, plus and minus. Now the angular bisectors are x plus y0 and x minus y minus 2, 0. By the way, since E02, the point we considered as E, doesn't satisfy both AC and CD, it cannot be on AC or CD, so the cutting points of A or D. So as far as they have recommended, the vertex to be, one of the vertices to be 0, 2, it should be B. So you can say therefore, E, B is E, so B is going to be 0, 2. See, with that mistake even, I got the answer in another way. That is an illusion. I mean, I recommended it to be, with that mistake, I got an answer where there is a possibility for other way. Yeah. Earlier CD was correct. AC was the wrong one. Earlier I got this x minus y minus 2 equals 0, but in the continuation I made it plus 2 0 after erasing the first answer. Is that so? X minus y minus 2 0. The thing is x minus y plus 2 0. Wait. So once I erase the things, I need your support once something goes wrong, right? By the way, you have 4x plus y plus 3 equals to x plus 4y minus 3, or 4x plus y plus 3 equals minus x minus 4y plus 3. There you have from these 3x minus 3y plus 6 0, x minus y plus 2 0. 3x minus 3y plus 6 0. And here 5x plus 5y 0, x plus y. Yeah. So this is right. Plus 2 is right. Plus 2 is right. Therefore, we have to consider this again. X plus y equals 0 is okay, and x minus y plus 2 0 is also okay. Then when we consider E to be 0 to, yeah, the point should be on CD. Either on C or D on CD. By the way, so again we have to correct this. This is done. It is not on by substituting E in x plus y. It is not on AC. We can surely say that. In the next, you are going to substitute E0 to in x minus y plus 2, x plus minus y plus 2 only. There you have to have, after substituting it, 0 minus 2 plus 2 is 0. So that is on CD. By the way, after finding the cutting point C to B, can you please recommend that cutting point we previously found? Oh, let us find that again, by the way. For C, we are solving x plus y 0 and minus y plus 2 0. Then by adding 1 to 2, 2x plus 2 is 0, x is minus 1, so y is plus 1. C is minus 1 plus 1. So the answer is correct. With the mistake. So eventually the answer is not correct. By the way, it is D now. Again, it is D. So C is minus 1 plus 1. So it is not C at all. 0, 2 is not C at all. Nothing in between C and D is for sure. And it should be D then. Therefore, you can surely say D is E with 0. So that is the vertex. D is the vertex. Is that clear? Right. Now, okay. I'll continue right away without giving you the time because we discussed so much no, there. So you are sure that we'll mark that here. D is 0, 2 for sure. Now let us continue. Further question number 8. Plus y. All right. The next. Show that there are such two squares and find equations of the sides of the two squares. Before to say there are such two squares, show that there are two such squares and find the equations of the sides of the two squares. They say. So you have to find the equations of these two sides. There you will have two possibilities. That is what they call. By the way, right. So let us think what to be done. Here you can write away say here gradient of AB is surely it is parallel to CD now. So it is going to be 1. Because of that, AB is parallel to CD. Then what about gradient of BD is minus 1. Because of that, BD is parallel to AC. BD is parallel to AC. BD is parallel to AC. Right. So next what you can do, you can find the equation of BD. After knowing the gradient to be minus 1, you can find the equation of BD. You know the gradient and 1 point. Then to find the equation of AB, that is where you have to think how to find the equation of AB. Let us see. So before to that, what about the equation of BD? When we consider about the equation of BD, the gradient is minus 1. So you can right away say equation of BD, y minus 2 over x minus 0 is minus 1. Y minus 2 is minus x. X plus y minus 2 is 0. That is for BD. That is for BD side. By the way, still we are like searching for that two equations as they say. Yeah, show that there are two such squares. So still, it is yet to be proven. We didn't have any clue as per now, by the way. So equation of BD is okay. Let us go for equation of AB. So you are so sure that the gradient of AB is 1. By the way, how to find the equation of AB? That is the issue here. You just know the gradient. After the gradient, what you can do is this. After the gradient, so I'll mark what I found here. I found BD2. BD is x plus y minus 2, 0. That is BD. X plus y minus 2, 0 is BD. Right. Thereby, yes. What do you think? What is the method in finding equation of AB? I think that is where we can show that we have two possibilities of the square. Correct? think what we need to do. Mm, yeah, there is one suggestion. Can't we find the points A and B and then find the equation of the line? Yeah, point A and B. Obviously, the things you can find in terms of the points is by solving these two, you can find C. By solving these two, you can find D. D is already known now. So you can find C only yet. No other things can be found up to now. So you have to go for a parameter or something. Yeah. Diagonals are perpendicular and diagonals are equal in length. Yeah, that is also good suggestion. Let's see what to be executed here. Right. So obviously, as per our like calculations and simplifications up to now, it is about AB where you have to have two answers, uh, hopefully, to determine for those two squares we are going to have. Is that clear? Right. So try to have that after completing the answer up to here. Try to have AB by your own suggestion. Then let us discuss the proper way. right? Did you have the method? So this is what we are going to do. We are going to find the angular bisectors of x plus y 0 and x minus y plus 2 0. In that way, apparently one of the angular bisectors should be going through B. But in the other orientation, what about the other angular bisector? It should also be going through B in this way without changing anything, right? So AB is to this side. So the same equation. B is going through the other angular bisector as well. So that is where we have two squares. That is the point. Clear? I was thinking how to have these two possibilities. The one possibility was clear. That is how with the angular bisectors again. So let us have considering angular bisector. Considering angular bisectors of AC and BC. AC and BC. There you have x plus y modulus over root 2 equals minus y plus 2 modulus over root 2. So x plus y equals minus y plus 2 over plus y equals minus 6 plus y minus 2. X to x, 2y equals 2, y equals 1, y to y, 2x equals minus 2, x equals minus 1. These are the two angular bisectors. By the way, in each of the times you have to solve these equations with this to have B. So let us solve for B. For B, you are solving this with x plus y minus 2 0 plus y minus 2 0, and here also you are solving x plus y minus 2 0. Yeah, so what about B? Here since y is 1, x is 1. Here since x is minus 1, y is 3. Therefore, B can either be 1 1 or B can be minus 1 3. Very good question, even though that is a little question. You don't have so much of the things given. Yeah, B is 1 1 no, B is minus 1 3. There you can decide the other side. AB has got the two possibilities. That is why how two squares are being formed. Then you can say here, therefore, the equations of AB. Therefore, ABE. So equation of AB is one is you already know the gradient to be 1. So y minus 1 of x minus 1 is 1. Y minus 1 is x minus 1. X equals y. X equals y. Oh, it means that x minus y equals 0. Or the other one is y minus 3 of x minus minus 1. X plus 1 is 1. So y minus 3 is x plus 1. Therefore, x minus y plus 4 0. These are two equations. So you can, after that you can mention, therefore we have two squares where AC, CD and BD are the same sides, equations of the same side. Equation can be the same even though this comes to here. It is the same equation for the same straight line. It goes from minus infinity to plus infinity. This is the same. This has to be here. So one square is this, the other square is this. Clear? So if you have any question, you can ask. It was a good question. Even though we took considerable time, yeah, we learned a lot from that question. Yes. Okay. So please complete. Then we'll go for the circle part. All right. So now we are going to do the circles part. Straight line done. Circles part. Part B. Part B. The circle is dash x squared plus y squared minus 2x plus 4y minus 3 equals 0 bisects the circle s equals 0. They have not given this. That is what we need to find, I think. If the point 1, 1 lies on s equals 0, so that the locus of the center of this circle is also a circle because it is a varying circle, not a constant circle, right? Right. So let's see. So that the locus of the center of this circle is also a circle and find its center and radius. Right. So it is about that bisection. Right. This is s dash equals 0, where s dash is x squared plus y squared minus 2x plus 4y minus 3 is 0. Bisect the circle is equal 0. So this is dash is equal 0. If the point 1, 1 lies on s equals 0, we don't know about that point. As well, let us name that point like this. Right. 1, 1 is on the circle is equal 0. So that the locus of the center of this circle is also a circle. Locus of the center of this circle is also a circle. Right. By the way, in this bisection, what you can say is, yeah, the common chord goes through the center of the bisected circle. So let us say C as the center here and C dash as the center there. So you can say let the circle is B x squared plus y squared plus 2x plus 2fy plus c0. As they have given 1, 1 is on the circle is, you can say since A1, 1 is on S0, 1 plus 1 plus 2g plus 2f plus c0. So 2g plus 2f plus c is minus 2. Equation number 1. Equation number 1. So next, you can see the common code. The common code. By the way, yeah. So they are how to have the common code. To have the common code, it is equation of a circle which is going through starting point of two circles. So there we have s plus lambda s dash 0. When lambda is minus 1, we have the straight line. So you can say equation of common chord. You are going to have it by s minus s dash 0. By the way, by making s and s dash equal, so it is going to be x squared plus y squared plus 2gx plus 2fy plus c equals to x squared plus y squared minus 2x plus 4y minus x squared y squared x squared y squared. Then further, right. So 2x to this side, 2 into g plus a, g plus 1 a. 4 to this side, plus 2 into f minus 2y plus c plus 3 equals 0. We should satisfy the center of s equals 0. We already have taken the center as minus d minus c by here. So you can say since these two is satisfied by, since 2 is satisfied by T minus G minus F. So 2 into G plus 1 minus G star, 2 into F minus 2 minus F plus C plus 3 equals 0. Further, minus 2G squared minus 2G minus 2F squared plus 4F plus C plus 3 0. There are even squares in there, ne? Right. Further, you have to find the locus, ne? It doesn't matter. It is about the locus. So let us go like this. You just have two equations here, ne? According to the given data. The given data are bisection of the circles and one lies zone. Yes. Center of the circle is also a circle. So you have to find the locus of G and F. The locus of G and F. That is what you need to find as the circle as they have given G and F. There, this is what I'm going to do. Yes. To have the relationship between G and F, the issue here is you just have two equations. If we have one more, we can right away solve for G and F. But it is not about solving. That is where we have to think. It is about connecting G and F to have a locus of a circle, another circle. It is about a simplification probably. By the way, this is what you can do. Up to here all logging. So please write down up to here. Equation number 1 and 3 only we need for the continuation. 1 and 3 we need. I mean, by 1 and 3 we are going to continue. By the way, build up the answer up to here, please. All okay. Right. Going forward, I told you that what we need is equations number 1 and 2 for the progression. So I'm going to erase this by the way. Hope you're okay with everything up to here. Yes, this is going to be the thing. To clear you further about the things, I'm going to consider 1 and 3 in some different manner, like this. Then you will have more clear idea. So I say let x is x bar and g, g is x bar and f is y bar. By the way, wait. Before that, so let us derive the relationship. Then I'll do that. Then I mean it is more suitable. By the way, this is what you do. By one, you can you have to connect G and F. You have to connect G and F. So I'm going to get rid of C. Then you can substitute C there. C is minus 2 minus G minus 2G minus 2A. C is minus 2A. To 2 you are substituting. From 1 minus 2 minus 2G minus A 2F to 2. Then you have minus 2G squared minus 2G minus 2F squared plus 4F plus C plus 3. So minus 2 minus 2G minus 2F plus 3 is 0. Alright, now our target is to show that this is a circle. By the way, let us take everything to the other side, then we can have pluses. 2G squared plus 2F squared minus 2G minus 2G minus 4G plus 4G to the other side. Plus 4F minus 2F plus 2F to the other side minus 2F. Constant. Minus 2 plus 3 plus 1 minus 1 equals 0 divided by 2. G squared plus F squared plus 2G minus 6 minus half is 0. Now you can see the circle. So now I'm going to do that. He has x bar and F has y bar. Let. Then you can see then is going to be x bar squared plus y bar squared plus 2x bar minus y bar minus half 0. Exactly. This is that standard format of a circle we just had. So you can say therefore center of S which is minus G minus F which is equivalent to minus x bar minus y bar now satisfied by this. So minus x bar minus y bar it should be. So obviously to go for that as it is minus x bar and minus y bar, yeah, you have to do some changes here. It is not about the locus of x bar and y bar, but minus x bar and minus y bar. They are x bar squared, y bar squared, and minus 2 minus x bar, minus 2 minus x bar, plus minus y bar. For the square terms, you don't have any change. Minus half 0. All right. Now, yeah, the center is satisfied by this particular circle. So you can see, therefore, minus x bar minus y bar is satisfied by which circle? X squared plus y squared minus 2x plus y minus half equals 0. That is the circle. Now you have to find the center and the radius. So you have to, as this is an essay question, you have to go for the basics. X minus 1 squared, x squared minus 2x plus 1 minus 1
plus y plus half square, y square plus y minus 1 by 4 minus half is 0. So x minus 1 square plus y plus half square minus 2 by 4 minus 3 by 4 minus 7 by 4 equals 7 by 4. Therefore, center of that circle is 1 minus half. It is better if you take this as y minus minus half. Y minus minus half. So 1 minus half. Radius is root 7 over 2 units. That is the radius.
Is that clear? Right. So please complete it. It is a good question, although it is just like in the instructions, it is like less instructions they have given comparatively, but all the points we have to think for the answer is like, yeah, really higher. So that is how once you practice the questions, this is not going to be hard at all, but you have to have the practice. Right? Please complete. All right, the next. It is like a different type of question for relative acceleration, by the way. Right. So I'll first do this relative acceleration part. Since our ongoing lesson is circular motion, I'm giving with the time I'm giving my priority to relative acceleration question. By the way, yeah, the wedge of mass 5m shown in the above figure with vertical cross section, the right angle ACB with tan theta is 4 by 3 is placed such that AB is in contact with the smooth horizontal plane. Two particles P and Q, each of mass m, which are connected by a light inextensible string, which passes over a small light smooth pulley fixed at C, are placed on the smooth surfaces of the wedge along AC and BC, and the system is released from rest. After time t, if the distance of the wedge from the fixed point O is x, and the distance from C to the particles P is y, by applying the law of conservation of momentum and the law of conservation of energy. So, two laws you are requested, you are required to apply. Show that law of conservation of momentum and the law of conservation of energy. For the momentum, you need the linear velocities. For the um, conservation of energy, you need the heights and mechanical energy. Height and the velocities. By the way, so let us draw this diagram, fetch this diagram, right? So X, C, U, E, M. This is going to be the 5mg. Theta and theta is 4 by 3. 5mg is weight. So you can mark that as 5mg for the weight and the forces, the reaction, the weight 10g, the weight 10g, R1. So this is R2 and the tension. Right. There you can have the velocity of which according to the displacements we have marked. You can see by uh, considering derivative with respect to time of the displacement, the velocity of which is relative to Earth is x dot. Then this is going to be marked as y next. I mean, they already have marked velocity of E with respect to h, by the way, is it is on page, is eta y dot. As it is connected by the string for q, the what we call the magnitude of velocity of q relative to wedge is also y dot. So it is going to be, this is 90, they have given there. So this is 90 minus theta. Pi by 2 minus theta y dot. All okay. Now by relative acceleration theorem, you need to have the real velocities.
which are considered to be velocities with respect to Earth. Velocity of T to Earth is going to be, yeah, the chart now we need y dot, and it is theta. Q to E is y dot, and here is x dot, which is pi by 2 minus theta. Pi by 2 minus theta. Then the law of conservation of momentum and the law of conservation of energy. Law of conservation of momentum. Right. So let us apply. Why we can apply the law of conservation of momentum? Because for this system, due to the direction of motion, you don't have any external force. That is why you can apply law of conservation of momentum as well law of conservation of energy. Both can be applied. You can say applying law of conservation of momentum. That is for the velocities. Likewise, we can right away apply for the accelerations as well by mentioning. You don't need to go from here. Just to mark these two is okay for the acceleration. Law of conservation of momentum. All right. Can we consider about the momentum? At first, you don't have any momentum of the system. So you know that for the new syllabus, we are not applying law of conservation of momentum, but for this application, since they request, we are going to apply, right? So next, it is going to be 5m into x dot plus m into for this direction, x dot minus y dot cos theta, x dot minus y dot cos theta plus m into x dot minus y dot cos 90 minus theta minus y dot cos 90 minus theta. Right, m2 into m. 0 is 5x dot plus x dot minus y dot cos theta. Tan theta is 4 by 3, so this is 5 obviously. Cos theta is 3 over 5. 3 over 5. Plus x dot again minus y dot. Cos 90 minus theta is sin theta, which is 4 over 5. 4 over 5. So 0 is going to be 7x dot 1, 2, 3. So 7x dot minus 3y dot minus 7y dot over 5. So 7 to 7 you can divide. 5x dot obviously, yes, 5x dot equals y dot. Is equation number 1. That is the question number 1 as well. That is the question number 1 as well. Right? Because 7 to 7 you divide 5x dot minus y dot into 5 again 0. 5x dot equals y dot. Is that clear? So please do up to here. Then try to apply by yourself conservation of energy.
All okay. So let's apply conservation of energy now. Mm, This is okay for you, right? Yeah, we are applying conservation of energy now. You can stay applying conservation of energy. Line conservation of energy. They are right. By the way, we have to consider something here. I'm going to consider to start. We don't know about the lens. That is the case at first. By the way, you know this as y. Let us have the total length of the string. Let L be the string length. String length. Total L be the string length. So I think it is better to have, yeah, this has potential energy zero limit. So there you have, yeah, let us start. At the start, you don't have any, and let us have this particular height as from here to here, h, simple h. So I mark that there. So at the start, you don't have any kinetic energy but potential energy. So that is going to be when you consider the weight, it is about as it is an object. So you have to consider for the what we call potential energy height for the center of gravity. So let us have height for the center of gravity. It is not h you have to consider. By the way, the height for the center of gravity. So it has, yeah, let us say that is it. It does not change by the way. Oh, it has this from here to here, h for center of gravity, right? In marking, you just like mark that like that can mention that it is the distance to the center of gravity. So by the way, it is 5 mgh minus 5 mgh, so 5 mg into minus h. Then further, this is y sine theta. So plus mg minus y sine theta. The other one plus mg, which is going to be L minus 1, L minus 1 cos theta. Sorry, L minus y cos theta. L minus y cos theta. Minus L minus y cos theta, and which is minus. Equal to now half into 5m x dot square plus half into m into y dot square plus half into m into y dot square. Because both are y dot. Now after that, in considering potential energy, is that 5 mg minus it doesn't change. And when you consider about these two, it is going to be uh, one is extended by c, let us say. So it should be plus mg minus y sine theta minus here plus mg minus L minus y cos theta previous. It is yeah, it is minus y cos theta minus, because you have to subtract minus c as it is like reduced there. By the way, here it is increased. That is why altogether minus, this is going to be plus c, right? So this is one application. Let us solve further. Mg minus m to mg minus a. So I'll erase this, otherwise I don't have enough space to simplify. In simplifying, you have here sine theta as 4/5. So minus mg y into 4/5 minus mg L minus p/5y equals 5m/2 x dot squared plus my dot squared all together minus mgy into sine theta 4/5, then minus mgc minus mgl plus mgy into 3/5 plus mgc. All right. Then what are the things you can cancel off? This to this, and yes, you can cancel off minus mgl to minus mgl, further plus mg plus mg. Right. All okay. So you are going to take all together a minus mg to plus mg plus mgc cancelled out. Then you have 5m/2 x dot squared plus my dot squared is as a constant. Yeah, we made the mistake. Now I'm thinking about the mistake what I committed, because we are not going to have the answer. The reason is we might have done mistake in the middle or in the application. There, let us think about the mistake. The mistake is, yeah, right. The thing is this: since we don't have any position change of what we call the wave. For the wave, we don't have any position change, but the velocity change only there. We don't need to consider about that what we call the potential energy. Potential energy stays the same. Where we had we had the change of the kinetic energy. All right. So the application is okay. In applying the application, it was okay. So let's see carefully. Yeah, that is the mistake I made, obviously. So I observed the applications clearly again. I couldn't find any error there. But the error I committed, the mistake I committed was where, obviously, in applying conservation of linear momentum, I applied it clearly with relative to Earth. But here, I just substituted with, I mean, we are okay with x dot, but for the y dots, all the other things are okay. You have to consider y dot here. In considering y dot, you have both x dot and y dot. There you have that x dot y dot product as well. That is the mistake. Can you see? Can you understand? For these two, it should be all the other things are correct. I mean, yeah, we carefully handle those things in having the distances and everything with potential energy. Where we made the mistake is here by considering, I mean, at the start I mentioned that I remember, but on the way I lost my track. That is why I made those two velocities as y dot instead of the velocities relative to Earth. Clear? So that is why you have to have the concentration in your mind without any disturbance in like following an answer. That is why. So in the middle, I lost my track. That is why. So it might be with my sickness, I don't have that much of concentration today. That is why I woke up later as well. By the way. So are you clear now? Do you need any further explanation? If you need, I can give you further. Is that okay? So that is why. I mean, just replace it by the correct values. I mean, the relative to Earth velocities, then all will be done. You will have this. So I'll guide you further. After the second equation, hence show that the acceleration of the wedge and the tension in the string Then to find the acceleration, you can, after having these two, it is about acceleration of the wedge length. Make x dot, make the equation in x dot only, then differentiate with respect to time to have x double dot. After that, apply for one particle f equals ma. By having y dot as well, there you need y dot. So with the answers f dot and the tension, then you have to have it. Is like another way of solving, but not all the questions, by the way, up to the given conditions, as far as the linear momentum and the energy is concerned, you can apply those. By the way, the recommended way is the normal way. If they recommend in this way, you can go in this way, right? We will discuss more questions like this. So hopefully, the session went well with you. You might have learned new things, and you might have understood your mistakes as well to improve yourself. That is what we need here. That is our target. So keep improving, keep doing the hard work. Don't give up at all. You can always think you can once you're mentally down. Uh, like that, I can't do. I need to give this up. This is going to be harder and harder. Don't give up because once you try in that moment where you need to give up, uh, you will at the end of the day you will be. You will be better. You'll be better. You will have a better result, right? So don't give up. Keep doing your hard work. If you have any issue, you can talk with me, right? So we will meet with the third paper, another paper by the next week. If you have any issue, please contact me with WhatsApp. Bye, everyone. Have a good day.